Okay, good afternoon, girls. Today we're going to talk about some more concepts in geometry and give you some more terms to learn. And I'll give you a summary at the very end of this with the terms and their definitions. And for now, I just want to talk through them. Now, the angles, mostly because it'll be angles we're talking today, that we'll be talking about are created, I suppose, when you see a structure like this here, okay? So we'll be talking about the angles that are created when you have two parallel lines and what's known as a transversal, or a line that crosses over the two parallel lines, okay? So two parallel lines, and we call this line here a transversal. So transverse is to cross over, okay? So this line crosses over these two lines, so it's a transversal. And you can see when you do draw this line to cross over these two, it creates a lot of angles, okay? So just looking at them, we've got an angle here, we've got an angle here, 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 and an angle here. So 8 new angles created by drawing this transversal across these two parallel lines. Now, all of the terms that we talk about today, they're only when a transversal is drawn across two parallel lines. It doesn't count in the same way if these two lines weren't parallel, okay? If these weren't parallel, then I suppose the ideas that we're going to talk about today would not be true, okay? So, for a start, since we're going to be talking about these 8 angles, I'm just going to give them a name, and the name I'm going to give them is a number to make it easier to deal with. So I'm going to call this angle 1, angle 2, angle 3, angle 4, angle 5, 6, 7, and 8. So those are my 8 angles labeled. Okay. Now, first thing we're going to see is that some of these angles have particular names. Okay. So angle 5 and angle 3 as a pair are known as alternate angles. Angle 5 and angle 3 here are alternate angles. I'm just going to write that up here. So angle 5 and angle 3 are alternate. So alternate angles. So alternate angles occur in pairs. You have to have 2 angles to be alternate. They occur in pairs. They are a particular pair of angles, which we'll explain later how you pick out which angles are alternate and which are not alternate. But a particular quality of alternate angles, if you do find 2 alternate angles, is that they are the same size. They are the same measure, if you like. So for instance, if this angle, it looks like an obtuse angle, doesn't it? We'll say that's about 100 degrees. If that's 100 degrees, then angle 3 is also 100 degrees, because alternate angles are always the same measure, the same size in degrees. Okay? Now, in this kind of a setup where you have 2 parallel lines and a transversal, there are always 2 pairs of alternate angles. 3 and 5 are the first pair. And what I'd like you to do is pause the video now and see if you can guess what the second pair is. Okay, so if you have paused and had a guess, the answer is it's 4 and 6. So I'm just going to write that down up here. 4 and angle 6, that's the notation we use, are also alternate. Oops, alternate. Okay. So angle 4 and angle 6, they both look like they are acute angles, less than 90 degrees. So for instance, if that was 100, then this must be 80 degrees. And if that's 80 degrees, then 4 is 80 degrees. 4 and 6 are both 80 degrees, for instance. Okay, so alternate angles, if they occur in a pair, they always must be equal to each other. 4 and 6, 5 and 3. We'll do a little demonstration in a moment that proves that they are definitely equal to each other. Okay. The next type of angle we're going to look at then are corresponding angles. Okay, now in this drawing again and again in a little while we'll go through an exercise that you can do to be able to pick out corresponding angles, so you'll be able to recognize them when you come across them. But in this particular drawing with these two parallel lines and the transversal, there are a number of pairs of corresponding angles. So I'm going to just write down corresponding angles, and I'm going to just list them here because there's quite a few. So first of all, angle 1 and angle 5 are corresponding angles. Angle 1 and angle 5. Okay, 1 and 5. Now corresponding angles are, just like alternate angles, they are equal in measure. In other words, they're the same size. So again, if that looks obtuse again, I'm going to say that's 100 degrees maybe. If angle 1 is 100 degrees, angle 5 must also, be 100 degrees. Okay, angle 1 and 5. Also, angle 4 and angle 8. So if that's, we'll say 80 degrees, then this must also be 80 degrees if they're a pair of corresponding angles. Okay. Next, going on to the other side, angle 2 and angle 6. Angle 2 and angle 6, corresponding angles, they must be the same size. And lastly, angle 3 and angle 7 are corresponding angles, a pair of corresponding angles. And angle 7. Okay. So that's corresponding angles. And again, we'll do a little proof of this in a moment, but we will also show you how to recognize them when you come across them. Okay. Next thing, I'm not going to write it down because you've done it already, really, but we have some pairs of vertically opposite angles that are created when we drew this transversal as well. So you've already done this with Mr. Mernan, but the vertically opposite angles are 1 and 3. They're opposite each other. They're equal in measure. They're the same size. Look, that's an obtuse angle. We say about 100 degrees. This is an obtuse angle. Must be 100 degrees if that one's 100 degrees. 2 and 4, vertically opposite. They're both acute angles. We say they're both 80 each. They're equal. Down here, 5 and 7. Those angles are equal in measure. They're vertically opposite. 6 and 8. They're also vertically opposite. So they're equal in measure. So they're the same size. Okay, one last thing I think we'll do before we move on, and this is the just a little bit of notation. Angle, when we draw two parallel lines and a transversal, these two in here, 3 and 6, are a pair of interior angles. And also angle 4 and angle 5. Now interior means inside, really, so they're all 4 of these are inside of the parallel lines, if you like. They're in between the two parallel lines as opposed to being outside. Okay, but there's something about them also, angle 4 and 5. Something about them also. Interior angles sum to 180 degrees. They're like supplementary angles. When you add them together, they add up to 180 degrees. So angle 3 is obtuse, we can see, and angle 6 is acute. So they're definitely not equal to each other, not like the pairs of corresponding angles and the pairs of alternate angles. But what we do know about them is if I added these two angles together, they give me 180 degrees. So interior angles sum to 180 degrees. They add up to 180 degrees. Okay, so that's the first thing. What we'll just move on to now is just a little proof to show you that yes, indeed, these alternate angles and these corresponding angles do equal each other. And it's a little visual proof. So I'm just going to pause this for a second so I can get something set up. Okay, so what I've done there while I paused the video was I took a scissors and I cut the paper in two here. So by doing that, and I'd like you to practice this at home just to see it, because it might be very hard to see in this video, I've created two sets of 4 angles. So 1, 2, 3, 4 here, and 1, 2, 3, 4 angles here. Okay, so if we wanted to check, for instance, we said that angle 2 and angle 6 were corresponding, were equal. What we could do, and as I say, we might not be able to see this in the video, I need lighter paper. If at home you're doing this, you place this exactly, this point here, or maybe this line, on top of this line. You'll be able to see the angles lining up. I don't know if you can see that, it's hard to see at home. You should be able to see that the angle 6 and the angle 2 line up perfectly. No, I don't think this is going to show very well in the video. Let me try and... No, you can't see through it unless you're... So try this yourself at home. Okay, since you couldn't really see the other way, what I've done is I've done a slightly different way of showing that these angles are equal. I cut out a section of paper here. I cut a section of paper where angle 6 was out of the drawing. Okay, and so then if I move this up, you can still see the size of the angle at 6 here. You can still see it by where it's cut. You just can't see the number. If I move that angle up and I place it on top of where angle 2 is, you can see that it's exactly the same size as angle 2. Is that okay? So maybe you could try that at home by cutting out some of these angles yourself and proving that indeed the ones that we said were corresponding were equal to each other, and the alternate ones were also equal to each other. Okay, so in the next video now we're going to move on in a moment to show you how would you be able to pick out which are the corresponding angles in a drawing like that and which are the alternate and the interior angles.